All right, so today what we're going to do is we're going to focus on drawing. This is an extension of the last video. So what we're going to do is we're going to focus on drawing the actual substituents. So there's two things to keep in mind when it comes to showing both both chair conformations, both the right leaning and the left leaning. So the idea is that the right leaning chair conformation will always have to be well, sorry, I lost my train of thought right there. But the idea is that the thing I want to tell you is actually much simpler. It's wedges up, dashes down. Okay, that's how I always learned it. So for example, let's say that we're going to work with cis 1,2 dimethyl cyclohexane. Okay, so to draw that out, just to draw this out, what we'll have here is we'll have let's see, we'll have our yeah, we'll have something like this. Okay. So this is cis. This is going to be called cis 1,2 dimethyl cyclohexane. So notice that that I'll just so that this will look like this relatively. Okay. And then these will be on wedges. Okay. So that's what we have. That's what we have right here. We have cis 1,2 dimethyl cyclohexane. Okay. So now what we're going to do is now we're going to look at this. Now we're going to look at this one, which is over here, and we're gonna number these. So basically, what we can do is we can say maybe this will be my actually, why don't we start? It doesn't matter where you start out with, but why don't we start out over here? So so let's say this can be our number one so this is our number one carbon. Doesn't matter how you number the carbons, but this is our number one carbon. This is our number two carbon. Okay, so you have your number one carbon and your number two carbon. So over here, we're gonna number it in a similar manner. So we have our number one here, and we have our number two right here. Okay, and then obviously these are just going to be H's. Okay, so these all have H's. So now we're going to put the substituents on here. Okay, so remember the rule: wedges up, dashes down. So because this is on a wedge, it means that it'll have to point upward. Somehow it'll have to point upward. Okay, and then the hydrogen over here is on a dash. So it means that it'll have to go down somehow, okay? So basically how we draw this is like so. So you see the wedge is up. So I'm going to write this here. Wedges up, dashes down, okay? So we draw this methyl here, okay? CH3, all right? And we'll draw this hydrogen down here, all right? Now, and then that means that over here, we're going to have the CH3 go up here, and then we're going to have the H go down here, okay? So please take care to notice that this was our molecule. And here what you can see is that that because both CH3s were both on wedges, because they're both on wedges, they're both pointing upward. One is pointing axial, one is axial, and one is equatorial. So this one over here is axial, and this one over here is equatorial. But either way, wedges up, dashes down. Okay. Now I'm going to tell you something else. So what this is just one chair conformation. Okay. So now what I'm going to do is I'm going to show you what this will look like on the other chair conformation. And please keep in mind that whenever we do a chair flip, two things happen. Okay. The first thing that happens is that the numbers switch. So you see how I arbitrarily assign this to number 1 and I arbitrarily assign this to number 2? Well, guess what happens? What happens is that when I switch when I do a chair flip, this will become my 1, and my 1 will be shifted here, moving this 2 to over here. Okay. So please keep that in mind, all right? And then the other thing that happens when you do a chair flip like this is that if it was axial, it'll now be equatorial. The wedges up, dashes down rule, that's still going to hold true, okay? But because because carbon number 2 was equatorial, it's now going to be axial when we do the chair flip over here. So let's take a look at what this would look like. So basically, what would happen is taking into account that the numbers are going to take into account that the numbers are going to switch a little bit. So here we have 1, 2, 3, 4, 5, and 6. And here you have an H here, an H here, H here, H here, H here, H here, H here. Okay? And then for over here, so this was our 1. All right? So our 1 was right here. So our 1 is now going to be down here. Okay? So now we're going to have our 1 here. We're going to have our 2 here. And then we're going to have 3, 4, 5, 6. Okay, so anyway, hopefully, hopefully you can see, how this varies. Looking at this one, the numbers kind of rotate. If you want to talk about how they rotate in a specific direction, you could say that they rotate going from a right-leaning chair to a left-leaning chair. They might rotate. You can clearly see the 1, which was up top, is now on the bottom. So you could call that maybe rotating clockwise, I guess. Yeah. Anyway, so now focusing on the rest of this. Drawing this. So because we have our carbons, our carbon numbers are still going to be conserved on here. We just have to put them. We just have to put them onto here. Okay. So when we put these onto here, what we'll have is we'll have a CH3 going up, right? So here's our CH3 on carbon number 1. So I'm talking about this one right here. So it's going to go up, okay? So you're going to have a CH3 going up, okay? And then this one, and then for carbon number 2, the CH3 is going to be going up again, okay? And the rest of these are all simply just going to be H's. So these are just H's. Okay, so those are all H's. Okay, so that's how it works. Now, as far as stability is concerned, The idea is that they're both going to be equally stable because regardless of which chair we're looking at, if we're looking at this one, we see that there's an axial methyl group and an equatorial methyl group, and when we go over here, we see that there's an axial methyl group and an equatorial ethyl group. So they're both going to have the same stability. So when we draw, the arrows show equilibrium, what this is going to look like is it's simply going to look like this. You'll just have it'll look like this. So both of these arrows will be the same length. So what we did though was we drew out the cis 1,2 dimethyl cyclohexane. But now what we can do is we can draw the trans 1,2 dimethyl cyclohexane, and maybe we might be able to figure out if they're of the same stability or not. So in the next video, we'll be drawing trans 1,2 cyclohexane. Okay.